Hi, everybody. It's Professor Mitchell, and today we're starting Chapter 3 on calculating descriptive statistics. So in this video, we'll look at Section 3.1 on measures of central tendency. Central tendency is a single value used to describe the center point of a data set. So the different measures of central tendency that we're going to be talking about are the mean and the weighted mean, the median, and the mode. And you might already be familiar with some of these. Starting with the mean, also known as the average, is the most common measure of central tendency. You calculate the mean by adding all the values in the data set and then dividing by the number of observations. So this you've definitely done before. This is what this formula looks like in statistics. It's a little intimidating to look at, but it really means exactly what we just said. So notation for the sample mean, X bar is used for the sample mean. X sub I are used for the values in the sample. So X1, X2, X3, etc. This symbol here is the Greek letter sigma, and in math that means add. So when you see a sigma and then this X sub I, it means add up all of the X sub I's, all of the values in the data set. And then N is the number of data values in the sample. So down here they're writing it two different ways. X bar is the sum of all the data values divided by N. Or you can write it like this, X1 plus X2 plus blah, 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 plus X sub N divided by N. The population mean works the same way. It just has a little bit of different notation. So instead of X bar for the population mean, we use the Greek letter mu. So you're going to be seeing this a lot later on this semester. And then for the number of data values in a population, we use capital N instead of lowercase n. It kind of makes sense if you think of a sample as being small, small n, think of a population as being large, large n. So here's an example. Suppose a sample of size n equals 5 gives the following values: 6.2, 7.1, 4.8, 9.0, 3.3. The sample mean, which is called X bar, would be the sum of all those values divided by N. So you add up the 6.2 plus 7.1 plus 4.8 plus 9 plus 3.3 and divide by 5, because that's how many values there are. Those values add up to 30.4. 30.4 divided by 5 is 6.08. And most statistics books have the practice for rounding that you round the mean to one more decimal place than is present in the original data. So since all of these original data points have one decimal place, the mean would be reported to 2 decimal places. All right, that brings us to the weighted mean. A weighted mean allows you to assign more weight to certain values and less weight to others. So the example that I always think of is your GPA. When you're taking a few classes and they're not all worth the same number of units, your grade in a 4-unit class would count more than your grade in a 3-unit class. So GPA is a type of weighted mean. The formula for the weighted mean is to take the sum of each data value times its weight and then divide by the sum of all the weights. So here's an example. Suppose you have already summarized the number of days you worked each week for a sample of size 20 weeks into this table. So there were 4 weeks when you worked 3 days. There were 7 weeks when you worked 4 days, 6 weeks when you worked 5 days, and 3 weeks when you worked 6 days. You worked 4 days the most and 6 days the least. To find an average number of days worked per week, you need to give more weight to 4 days and less weight to 6 days. The frequencies represent the weights. All right, so here's how you would calculate that weighted mean. You do 4 times 3 plus 7 times 4 plus 6 times 5 plus 3 times 6, and then divide by the sum of the weights, which is 4 plus 7 plus 6 plus 3. So doing that calculation, you get 12 plus 28 plus 30 plus 18, which is 88, divided by 20. And so 88 divided by 20 comes out to 4.4. So the average number of days you worked per week is 4.4 days. All right, let's see. Advantages and disadvantages of using the mean to summarize data. The advantages are that it's simple to calculate and it summarizes the data with a single value. The disadvantages are that with only a summary value, you lose information about the original data. So compare these two samples of size 3. If one sample was 999, 1000, and 1001, the mean of those values is 1000. But if the second sample, the values were 0, 1000, and 2000, the mean of those is also 1000. And obviously they are very different samples. The mean can't tell the difference between those two. So just knowing the mean does not help you know what the underlying data looks like. Another disadvantage of the mean is that it is sensitive to outliers, which are values that are much higher or lower than most of the data. So when I'm using a measure of central tendency to summarize a set of exam scores, I usually don't use the mean because oftentimes there are 1 or 2 unusually high or unusually low scores, and those affect the mean. So for those, I actually like to use the median. The median is the value in the data set for which half the observations are higher and half the observations are lower. So the way that you find the median is to first arrange the data in ascending order and then use an index point to determine the position of the median in the data set. Now, before I go any further, I want to tell you that I actually changed the way that they define this index point. I thought the way that they had it set up in the PowerPoint was very confusing. So the reason I'm telling you that is because if you're using online homework and you use any of the help buttons like show me an example or help me solve this, they might explain it a little differently. So I'm not trying to confuse you. I'm actually trying to give you the simplest explanation. So the way that I calculate the index point is to take n plus 1 and then multiply that by 0.5, which is the same thing as dividing it by 2, where n is the number of data points. And whenever that index point is not a whole number, use the mean of the 2 closest whole numbers, the surrounding whole numbers. So for example, if the index point came out to 9.5, that means the median is the mean of the 9th and 10th value. And you'll see an example of that here in a sec. So for example, with a sample of size n equals 7, notice that these values are already in ascending order. The index number, as I define it, is I equals 0.5 times n plus 1, which is 0.5 times 8, which is 4. So that means the median is the 4th position in the sorted data. So the median for this sample would be 28. The median is not sensitive to outliers. If we change that 50 to a 5,000, the median would still be 28. So that's why I like to use it for exam scores, for example. When there are an odd number of data values, like there are in this example, the median is always the middle value in the data set. Now, what about when the number of data values is even? Then the index point, as I define it, does not come out to be a whole number. Specifically, it ends in a 0.5. That would be if your data values are whole numbers, I guess. No, that would be always, never mind. All right. So the median in this case would be the mean of the two surrounding values. When there are an even number of data values, the median is halfway between the two middle values. So for example, with a sample of size n equals 6, the index number, as I define it, would be 0.5 times n plus 1, which is 0.5 times 7, which comes out to 3.5. Since the index number is not a whole number, the median is halfway between the third and fourth values in the sorted data. The third value is 170. The fourth value is 182. So the median would be the mean of 170 and 182, which is 176. All right, and that brings us to the mode. The mode is the value that appears most often in a data set. If no data value or category repeats more than once, then we say that the mode does not exist. More than one mode can exist if two or more values tie for most frequent. And the mode is a particularly useful way to describe categorical data, right? Data that it doesn't make sense to do any math with. Okay, so, but here's an example with numerical data. The number of children per family in a sample of 24 families is given here. So if you put these data in a frequency table, the value that appears most often is 2, which occurs 8 times, which means the mode is 2 children. Here's an example with categorical data. If you were to look at the cars in a parking lot and write down, how many are there of each model of cars? There are 3 Acuras, 5 Fords, 1 BMW, and 7 Toyotas. The car that appears most often is the Toyota, which occurs 7 times. So the mode is the Toyota model. In this particular example, there is no way to do the median or the mean. It just doesn't make any sense. Not only can you not add all these things together and then divide by how many there are, but for the median, you have to at least be able to put them in some kind of meaningful order. And you can't do that with car models. Car model is numerical data. Nominal data, not numerical. Definitely not numerical. All right, so here's an example where we're finding all 3 types of measures of central tendency. The prices for 5 homes have been collected, and those 5 prices are $2 million, $500,000, $300,000, $100,000, and $100,000. So the mean would be add those up and divide by how many there are. The mean comes out to $600,000. Notice that that's higher than 4 out of the 5 homes on the list. So that makes it maybe not the greatest measure of central tendency in this example, and it's because of this, really high priced house, right? That's an outlier. The median is the middle value of the ranked data. So since there are 5 values, 5 plus 1 is 6. 6 divided by 2 is 3. So the third value would be the median, and that's 300,000. I think that's a better measure of central tendency in this example. And then the mode is the value which appears most often. That's the 100,000. Little bit about shapes of frequency distributions. So these things are histograms, like we talked about in chapter 2. When you have this kind of situation, that distribution is called symmetric. And the mean and the median are either equal or very close to being equal. If your distribution is not symmetric, it might be skewed. And there are two different types of skewed. There's left skewed and right skewed. Now, I've always thought it's really counterintuitive which one is called left skewed and which one is called right skewed. So I picked up a great way to remember this from one of my students over the summer. If you think of these things as being like your toes, this looks more like the toes on your left foot, that's left skewed. This looks more like the toes on your right foot, that's right skewed. Makes it really easy to remember. So this is like what happens in a class when I give an exam that is either too easy, this one, all right, most of the grades are A's and B's, either that or the class studied really hard, that's another possibility, or either the exam was too hard or the class didn't study, all right, would give you a right skewed distribution. All right. The last few slides just deal with Excel. And again, I'm not doing much with Excel at this point in the semester, but I will show you how this works. So you find the mean or the median or the mode using a formula. The formula for mean is called average. Excel does not know the word mean. And you put in the range of cells where your data are. Same thing for the median. And then I've actually never used the mode formula in Excel, so it looks like mode.sngl. I'm not exactly sure what that means, but I could take a guess. I'm not going to bother. All right, so that's how that works. And I'll say this again later when I actually use Excel. Data analysis, I'm not going to do anything with that right now. Descriptive statistics, I'm not going to do anything with that right now. All right, so which measure of central tendency should you use? The mean is generally used as it is relatively easy to determine and most widely understood by people with little statistical training. However, if outliers are present, the median is often used since the median is not sensitive to outliers. For example, median home prices may be reported for a region because it's less sensitive to outliers. And of course, for categorical data, the mode is the only choice. All right, so this table summarizes the advantages and disadvantages of using the mean, the median, and the mode. We already talked about the advantages and disadvantages of the mean. Advantage of the median, it's not affected by extreme outliers. Disadvantage of the median, it requires the most effort to determine when compared to the mean. And then for the mode, the advantage is it can be used with categorical values. The other two can't. However, disadvantages, it might not exist in some data sets, and it might not be unique. There may be more than one mode. So that's going to take care of section 3.1. Yes, this video was longer than the last few we had in chapter 2. We got a little spoiled there. So from this point forward, you might expect videos that are about this length. And we will see you next time.